G'day team and welcome back to another video, and today we're going to be talking about the normal distribution and then looking at ways we can solve it using the given values or using our calculator as well. So anything in life that is to do with measurement basically can be sort of looked at with a normal distribution. So typically we're looking at something that's measured, so the weight of a can or the size of an apple. And what happens is the weights or the sizes or whatever you want to look at sort of sit around the average or the mean. So that's our mu again. So mu equals mean. And then either side of the mean, they could be a little bit above or a little bit below. And what we can do is with a certain spread, we can actually calculate the probability of certain apples or oranges or weights of cans being in a specific range. So that spread I'm talking about is this standard deviation. Okay, so sigma standard deviation. So our random variable x, we would say, is normally distributed with mean, mu, and standard deviation sigma, but we write the variance inside of our distribution. Now, a normal distribution has this nice bell curve, and what we do is center it around the mean, and we add 3 standard deviations either side, and we subtract 3 standard deviations either side. And you can see a certain percentage or probability or proportion of anything will fit within a certain range. So this is saying that between the mean and 1 standard deviation above the mean, 34.13% of my items will be within that range. If we add up all of these numbers, we get about 99.97%, which means pretty much all of my things lie nearly within 3 standard deviations of the mean. So one thing we're going to look at is drawing different normal distributions. What you've got to look at is the area under this curve is always equal to 1. So if I have a more spread out curve, that's going to be shorter than a less spread out curve because the area has to stay the same. If I make the width even smaller, then the area has to go somewhere, so it goes up. So I like to use the rhyme smaller normal distribution or smaller standard deviation, taller distribution curve. So let's have a look at this first one here. So I've got mu equals 20 and standard deviation equals 5. So let's put in just my middle because I know that's my mean. Now, because I have a standard deviation of 5, I'm going to go 3 times 5 to the left and 3 times 5 to the right, and that's going to be approximately where I draw my curve. So 3 times 5 is 15, so I'm going to go to at least 5 and at least 35. So then I just draw in my nice bell curve with arrows a little bit further than that 3 distribution. So that is my curve A. Now, if I'm looking at this next one, I've got a mean of 16, which means I've transferred over to about here. So that's where my mean's going to be. Now, my standard deviation is smaller, which means it's less spread out. So that means my curve has to be taller. Now, you don't have to get it proportionally correct as long as it is approximate. Now, that's not quite going to be 16, it's about 15. Let's put in there, draw our line through there so you can see the means are clearly different. 2 times 3 is 6, so I'm going to go to at least 10 and at least 22, which is going to be about here. And then you draw in your curve, and you can see I've got my 2 different curves that are very clearly different. Now, the next thing we can do with normal distribution is calculate the probabilities of certain things being in a certain range. So I've got here the height of students in Year 12 methods has a mean of 175 centimeters and a standard deviation of 5.5 centimeters. We want to find the probability that x is less than or equal to 175, probability that x is greater than or equal to 180.5, and a probability that x is between 164 and 180.5. So I've gone ahead and drawn the little curve, and a bit of dodgy numbers there, but we can use it to our advantage with these percentages up here. So if I'm looking at probability that x is less than or equal to 175, that's this bit, this bit, this bit, and this bit, and it's all the area to the left of the mean, which means it is just 0.5. Nice and simple there. If I'm looking at the area bigger than 180.5, I add up this area, and this area, and that actually comes out to be 0.1587 as a decimal, as a proportion. The next one, we're looking between 164 and 180.5. So 164 to 180.5. So I'm adding 13.59 to 34.13 plus another 34.13, and I get 0.8185. So they're the probabilities that a certain randomly selected student will be within that height range. Now, the other thing we can do is use our calculator, because sometimes we're not going to be given these values that are perfect standard deviations away. So we need a way to do this. Now, there's two ways on the graphics calculator, the Casio, that you can do this with. The way we did our binomials is probably the easiest because then you're in the same little spot. So you've got menu, then statistics, distribution, norm, and we're only going to use NCD for now. Or you can go menu, in your run matrix, option, stat, distribution, normal, NCD as well. So I prefer this first method because it's a nice list. You can just list it down. Now you got to be careful, so because you're going to input an upper limit and a lower limit. If I've got the probability that big capital X is greater than little x, the value, in my upper limit, I put times 10 to the 99. Now this is just a really, really big number. And then the probability that x is less than or equal to x, my lower limit will be negative times 10 to the 99, which is a really negative number. And we just approximate that that's using all of the numbers in that area. So let's have a look at a question. So let X be the weight in grams of bags of sugar filled by a machine. Bags less than 500 grams are considered underweight. Now, X is normally distributed with a mean of 503 and a standard deviation of 2. Not 4, just the 2. So what percentage of bags are underweight? So we're told that if the bag weighs less than 500 grams, so we want to find the probability that X is less than or equal to less than, doesn't matter in continuous variables. So we'll write less than 500. So if you're using the first method, you have your lower, your upper, standard deviation, and your mean. So in this case, my lower limit, if I'm looking up here, I've got less than x, so I want negative times 10. So 1 times 10 to the 99. My upper limit is going to be 500. My standard deviation is 2, and my mean is 503. So if I quickly go ahead and put those numbers in, 503, we get the probability, little p, is equal to approximately 0.0668. So about 6.7% of my bags will be underweight. Now, if 20 bags are randomly selected, what is the probability that 2 or fewer bags are underweight? Now, this is a bit of a trick question because it's actually swapped from normal distribution to binomial distribution because we're counting number of bags. So the first thing is to define or let Y be the number of bags that are underweight. So the number of bags which are underweight. Now we want to find the probability that we get 2 or fewer bags. So the probability that Y is less than or equal to 2. Now in binomial, that less than equal to 2 sign is really important. So we're going to go back onto our calculator, but go to BCD now. So we're going to use BCD. Now in BCD, we have our lower, we have our upper, we have our number of trials, and we have our probability. So my lower value is going to be negative times 1099. My upper is going to be 2. The number of trials is 20 bags, and the probability that a bag is underweight is the value we calculated in A. 0.0668. So the probability that this is true, that 2 or less bags are underweight, 0.0668 is 0.854 approximately. So pretty high chance that we're going to have 2 or less bags underweight. Hopefully that helps, and thank you for watching. I'll see you in the next video.